Hey everybody, it's Craig here. It's a snowy Sunday afternoon. I'm down here in my man cave, and I thought I haven't streamed thing for a little while. I haven't been on the online, so I thought I would take this opportunity to try it out again. Today I want to talk about a little project that I've worked on a long time ago. It was a kit that I produced called a Flitterbug, and the idea behind the Flitterbug is it's what's called a solar engine. With that solar engine is you got a little solar cell, you can see there, and a motor. And the solar cell will gather energy from the sun, charge up some capacitors on board, and when it hits a certain threshold, it dumps it to the motor and spins it. Now, there's lots of stuff you can do with the Flitterbug once you actually finish it. It's just a very inexpensive but fun to build kit, and you can be very creative in how it operates. You can see right here the Flitterbug design. You can turn it into a floater bug, a little robot that swims around in the water. You can turn it into a jitterbug, a robot that shakes and rattles all over the table. You can make it a little robot animal that runs around and avoids obstacles, or you can make it a plant, and the plant itself could just rotate if you like, or you can attach an insect to it. Here's a Flitterbug. I'll just turn this little light on so we can get some solar energy going, and you can see it's just tied to a butterfly in this case, and that little engine just kicks that little butterfly around all day long. Here's another one, similar in design. The Flitterbug engine, the circuit board is up at the top with this little mason jar, and inside the mason jar is a little flower on the bottom and a little bug inside it. Let's see if I can get some light on it. Hello, is it working? There it is. And you can see the little bug flies around uh, when it's in the sunshine. So let's just go to that bench over there. I'll put one of these together, show you how to solder, how the kit actually works, and we'll take it from there. Okay, well, I'm over here now at the workbench. Everything seems to be working. Just before we get going with the soldering, I'd like to just encourage everyone here to make sure they have some good safety glasses here, my old special bifocal safety glasses, so I can see some up close work. You don't want to get any resin or flux or solder in your eyes when you're working on these things. Good safety precaution. And when you're done, I recommend that you do wash your hands, get the solder off your hands. Probably not a good thing to ingest. Some tools I think you should have in advance before you begin soldering. You should have a good pair of small electronics pliers, some side cutters. We're going to be doing some clipping. This is a special tool I use for bending resistors. You don't have to have one of these. You can do this with just pliers. I like to have a little straight edge razor just in case I have to cut some things. And finally, it's a good idea to have a hot glue gun to kind of put things all together. You'll need a hot glue gun when you finish this off as well. So let's open up the Flitterbug and see what we got here. This is the kit, and we have inside all kinds of goodies. Most important thing of all, of course, is the instructions itself. This gives you all the assembly notes on how to put this thing together, the tools required, a little bit about soldering, how to properly solder components, and how to assemble your Flitterbug. And in the last page, it talks to you about how to put it in this various configurations. But the first thing we're going to have to decide is, do we want our robot to be a plant or an animal? And the animals move around, the plants sort of stay still. And this is my little kit of parts. You can see all the components you need for the Flitterbug are right there. A little flower, comes with a little insect on a bit of a wire you can put on as well. And so we'll leave the flower for now. Let's start by opening up the kit, and we could use my little razor blade for this, or scissors if you got them. Scissors are a good idea. Now, very often it's a great idea to have some egg trays perhaps, or a little muffin pan like this to hold all your parts in, or anything you want to keep the parts from rolling off the ground. There's some very, very small parts in here, and you don't want to lose them. This is a flexible solar cell right here. Very, very cool, unbreakable. And we got our electronic components in the middle part here. Got the electronic components, And on the top we have the circuit board and some of the basic wires. There we go. So you can see there's the motor, little motor that's going to be involved. We have these devices. This is our energy storage device. These are called capacitors. Each one of those is about 1,000 microfarads. We have a voltage trigger and a transistor that we're going to be putting into our circuit board, and then the circuit board itself. And you can see there's two sides. There's the top side with the silk screen on it and all the components labeled on there, and this is the bottom of the board. Good idea when you're soldering, make sure you solder to the top of the board. All right, well, let's see, where are we going to start? I think the best place to start would be putting the resistors on, and you can see there's a couple of 100,000 ohm resistors right here. I'm going to pull the paper off those, and I can just take the end of the resistors and I can bend them quite sharply down with the pliers, and we're going to put those in the holes marked 100,000 ohms. These aren't polarity sensitive devices. The resistors can be put in either way. The function of the resistor is just to limit current flow. So the resistance will actually cause the current to be reduced, sort of like water is reduced in its flow through a water hose if you drive over the hose with a car. Okay, I'm going to put those two little resistors into the circuit board. Okay, now at this point we could solder, but I think yeah, let's go ahead and solder these boards in. I've got the resistors nice and flush to the circuit board. So to solder, I've already got my soldering iron nice and hot. I have my sponge damp. I'm able to wipe it off. If your solder isn't nice and bright, you can use some steel wool or something to clean the tip until it's nice and bright silver. And I'm going to take some solder and I'm going to wet the tip of the iron. That helps conduct the heat. This thing right here is this is a little vacuum that helps suck the fumes away. You don't have to have one of these, but if you can avoid breathing the fumes, that's probably a really good idea. All right, got my safety glasses on, and here we go. So we're going to solder in the resistors. There we go. 1, 2, 3, 4. Okay, well, maybe a little bit more on that last connection. Now, there was a lot of great videos out on the internet about how to solder. I'm not going to go into too much detail on that right now, but I've got the resistors soldered on. Now, it's usually, to solder professionally, it's much better to cut the wires first and then solder, because if you do it the way I did, solder and then cut, the impact of the cutting may cause solder fractures in there. But there we go. That's looking pretty good. Now, if you do have some isopropyl alcohol, some 99% isopropyl alcohol, this would be a good time to put a little of that on a brush, maybe an old toothbrush, and then just clean off that rosin from the flux from the solder. It's also a good idea to clean the whole board off, just in case you got any oil from your fingers on the circuit board. Okay, so next we're going to put in the transistor. The transistor we have is an MPSA12, and there it is, right there. There's a flat side on the board right here, and a flat side on your transistor. You'll just line those up and stick it in. Make sure it's nice and straight. And I'm also going to put in the voltage trigger, the 34164, on the other side, and I'm going to make sure it's all nice and straight too, so we can see the transistors are on good. I'll flip it upside down, and I'm going to solder on just one of the 3 leads on each one, the middle one, real fast. There we go. And while the one is soldered on, that gives me a chance to straighten out the components so they look good, standing up like little soldiers. The transistor is an electronic switch. It's going to be turning the voltage on and off to the motor, and the voltage trigger is going to be monitoring the voltage level on the capacitors. And when the voltage level gets to a certain threshold, a certain set point, it'll signal the transistor to turn on and dump all the energy from the capacitors to the motor. Okay, next thing we want to do is capacitors. Now at this stage, we want to decide if we want this thing to be a plant or an animal. And I've done a few plants now, so I think I'm going to try building a little animal to see how that's going to work out. If you do an animal, you have to do all the components on the top side. That's the most important thing. With the plant, you can put the capacitors facing down on this side of the board like this. But for an animal, we're going to place the capacitors facing up. Now the capacitors have a polarity. This big white side right here marks the negative side. It's also the shorter of the two leads on the capacitor. And you can see there's positive and negative marked on the capacitor here. So I'm just going to put that in there like that. I'm going to just spread the lead so it doesn't pop out. And I'm going to put all 4 capacitors in real fast. And there's the second one. Capacitors are basically storage elements. They'll take the electrons and store them inside, just like a balloon will store air pressure, and then you can release that air pressure whenever you want to get it later on. So that's what the capacitors are. They're going to store the energy that's going to be brought in from the solar cell. And I'm going to quickly solder those on. There's one, 2, 3, and 4. Get that little vacuum here a little closer. Suck up some of those fumes. Whew. I love the smell of solder in the morning. All right, so, and now I've got all the capacitors soldered in. I'm just checking the other side to make sure the polarity is okay. And they're all nice and flush to the board. And they are. I think they're looking really good. So let's snip off the excess leads. There we go. Yep. Alley-oop. 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 Okay. And pick the excess wires and put them someplace else. Okay, we're getting very close to the end, believe it or not. So we're going to turn it into an animal. So if it was to be a plant, these little jumpers right here, I would have to bridge them with a little bit of solder. But it's not going to be a plant, it's going to be an animal. So you don't have to do that. The animal is going to have its little motor facing down instead of up. So the motor would be placed in like this, and I rotate the motor till the 2 screws are visible in the holes. And there's a couple little screws that we're going to have to set up. So here's a screw. Excuse my big fat fingers. Put the washer on the screw. Put the motor through the hole. Line up the screw holes. And tuck it in. Now, one thing I didn't mention that probably would have been useful is a screwdriver. So get a little tiny Phillips screwdriver like this one and screw it in. Okay, that's good for that side. And then we're going to take another screw and we're going to screw it in the other side like that. Yeah, there was a friend of mine, Evan Hackler, who's in Australia right now, a bit of a genius. He helped me quite a bit with the circuit board layout back in the day. It was really wonderful to work with him. Okay, so now we have the motor attached, as you can see, like that. And we're just about done. Now we have to attach the motors, and we have to attach the solar cells and attach the wheel. So let's take care of that. Let's start with the motor. I'm going to take a little piece of wire. Now you can use the wire that's in the kit. I'm going to just use a little wire out of my my wire tray here, and we're just going to cut and strip a little insulation off one end of this, we're going to put it into the negative connection for the motor. There we go. And we're going to take another piece of wire, and we're going to make this one go in the other connection. And that goes right into this little hole right here. And we're just going to solder that on there. There we go. And clip off the excess. And these are going to go to the motor. Now I'm going to clip these to about the same length. I would say about that long, and that long should do it. That's all I need to make it to those motor terminals. And I'm going to strip off a little bit of the wire from the top. Oopsie, there we go. And I'm going to put this into one side of the motor and put this conductor into the other side of the motor. You can see right there. It doesn't really matter which polarity it is. The motor's either going to spin one way or the other. So there we see it, ready to go. Now let's solder those wires onto the motor. There we go. And we'll just trim off the excess. I think I'd like to have a little more solder on this one pole right here. It's not quite completely soldered yet. So let's get a bit more solder on there. Wonderful. Okay. Okay, the motor's now soldered. Now we're going to have to attach the solar cell. So the solar cell's got a polarity to it, just like a battery does. You have to be kind of careful how you put the solar cell together. You can tell the polarity by looking at these little lines on the solar cell. And the lines where they're pointing to, you can see here, is the negative side. So this side over here is negative. That side's positive on the solar cell. Now there's actually a plastic coating on this which burns away with a soldering iron. So I'm going to go on here and I'm going to just apply solder and melt it right through the plastic until it forms a nice connection onto the conductor underneath. Just like that. All right, and we're going to do the same thing to the other side. There we go. Just like that. Okay, now we're going to take some more wire, positive and negative, and I'll use it from my own supply here. Red for positive, black for negative. We'll just snip that off. And we'll strip a little wire off the positive side. I'm going to put a little solder on the wire. It's called tinning the wire. And I'm going to attach it to the positive side of our solar cell. This is a silicon solar cell. So photons, light particles from your light source, will come down to the silicon atoms on here, strike the atoms, add energy to those atoms, and kick the electrons off of the outer orbital of the silicon into free space, and those electrons can then conduct, move from the positive to the negative side, and that's all there is to silicon solar cells. There we go. There we have the positive and the negative on here, and now if you look over here on the one side of the circuit board, right in there, you'll see the solar connections, positive and negative. Now, I think in hindsight, it would have made those probably further apart if I had a choice. But, well, that's how they are, and it's not that difficult to work with. So I'll strip a little off the positive side, and strip a little insulation off the negative side, like this. Okay. And I'll tin them. Thusly, my soldering irons are getting a little messy on the end, so I'll clean that off. Tin them. There we go. And I'll just tin the other side. There we go. Clip the raggedy end off. Raggedy end off. And I'll insert them onto the circuit board. This should be my last soldering I have to do. Negative into one side and positive into the side marked with the plus. Positive on the side with the plus. There we go. And I'll trim off the excess. Now that's the last soldering I have to do. So this is probably a good chance for me to clean up the bottom of the board a bit as well to make get rid of the flux and make all the solder joints nice and bright and shiny. Yeah, it's good. Yeah. Oh yeah, much better. Yeah, that flux can actually over time degrade the solder joint, so it's probably a good idea to get rid of it anyways. Degrading is bad, and looking kind of ratty is bad too, so there we go. That's looking pretty good. Okay, so everything's sort of coming to an end now. We just have one more thing to do. If I want to make this thing into a little animal, we have to put a wheel on the bottom. Now the wheels are nothing more than a piece of glue stick, right? And to make the wheel go on the shaft, all I do is I just kind of melt a little hole in the middle, and while it's still molten, I put it on the shaft of the Flitterbug like that, and we have the wheel mounted, and our Flitterbug is ready to go. So at this point, I've got quite a bit of wire on here, so I think what I'm going to do is just sort of twist the wire to make it shorter. Twist the wire to combine the red and the black into one big wire. There we go. Okay, now let's see if this is going to work. All right, so we've got the, I've just kind of twisted the red and black wires here to shorten up the leads a bit. We've got the wheel on the bottom. It's in animal mode. Let's just put some finishing touches on. One thing I did do is I took a pair of scissors and I just trimmed the corner of the solar cells just to take the rough edges off, make it look a little better. I got to be careful not to trim too much into the black, because when I start cutting into the black, I'm cutting into the actual photovoltaic portion of this cell, and it's going to really affect its performance. So I just trimmed the corners, and now let's attach it. The quickest way to attach it is just get a little hot glue gun and put a bead of hot glue on the end of the little DC motor here, just like that, and then put the solar cell nicely centered into that hot glue. So I'm just going to set it there on the top. I'm going to hold it for a moment until the glue hardens, and then the solar, a little solar roller is ready to go, our little Flitterbug. So let's go take it over to the light and see how it works. Well, our little robot kit's all done now, and here it is, solar cell on top, motor in the top of the circuit board, and the wheel in the bottom, because it's in animal mode. All right, let's see if this thing's going to work. I'll just set it on the surface right here. I've got about 1,000 lumen LED flood lamp, which is just about as good as the sun, maybe half as good. And we present some photons onto our little robot. He absorbs them, turns them into electrons, charges up the capacitor, and when it hits a certain threshold, dumps the charge across the motor terminals, and the little robot starts to scamper all around its environment, bumping into things, and if it bumps into something and flips over, it'll change direction. That's how it changes direction. See, here it's going to the left, tilt it that way, it goes to the right. And I'll bring the little solar powered plant mode back on just to demonstrate the plant mode again. You can see in a window a very active thing. And here's another example. The circuit board's up at the top. I've glued it at the top of the mason jar here, and the butterfly is on the bottom, and you can see the butterfly now dancing around inside the mason jar, or whatever kind of insect you want. We got all kinds of ladybugs and bees and all kinds of things in there you can build. It's a real fun little kit. I've enjoyed designing it. And I have a lot of fun making them. If you're interested in getting one of these kits, they're very reasonable. Just email me down at the bottom there, and I can set up a way of getting them to you if you're interested. But if you're not, that's fine too. I'm just glad you came on board and watched this whole video all the way through, maybe learned a little bit about some electronics, and I hope to see you next time. Have a great day.